Okay, let's take a look at these questions. I thought maybe the easiest thing to do was to just kind of pull up what you've been looking at. So if I pull up the problems that you've been looking at most recently, just kind of get some white space here going. It looks like these composition of two functions are the ones that you were asking about. So if I look at, for example, this one. Okay, so you are asking about domain. There's no real quick, you use greater than or equal to in this case, less than or equal to in this case. I think it's more that you need to think about the different situations that occur and how to deal with them. So when you're looking at, so let's see, here's the function. So it looks like you came up with the right function. So when your function is, here, let me grab a pen. So when your function is something like 2x minus 11 over 2x minus 6. So this is a fraction. When you're dealing with a fraction, some number over another number, really the only thing that can't happen is that the denominator can't be 0. I can't divide by 0. So that's the only thing that I have to look out for. So in this case, I would just consider the denominator and the situations that would make it 0. So if you just set up an equation or a non-equation, 2x minus 6 can't be 0, then 2x can't be 6, and x can't be 3. So 3 is the only number that is going to create a situation that this is undefined. When x is equal to 3, I would get 2 times 3 or 6. 6 minus 6 equals 0. I would get some number over 0, and that can't happen. So for my domain, it's really all real numbers, except x can't be 3, because then I get something that's undefined. So that's, again, when you have just, a rational function. Now, if you look at some of these other ones, let's see, let's close this one. So then the next one that you took a look at was here. So let's see what we have. Okay, so again, oh, that was the same one. All right, let's look at this one. Okay, so now in this case, if you notice, you kind of went with a solution similar to the one that we just talked about. So the one that we just talked about, again, just excluding 3, if you were to write this one in interval notation, again, consider the number line. 3 is the only number that I have to exclude. I want everything else. So the interval notation is negative infinity to 3 or 3 to infinity. So now when you're looking at this one, here I have the function that you came up with, and again, you came up with the right composite function. So the function is the square root of 3x plus 6. Okay, this is not a fraction. This is not a rational function. It's a square root function. So again, what I have to think to myself is, what can't happen? So what can't happen is I can't square root a negative number. So that means whatever is under the radical, so here's under the radical is 3x plus 6, 3x plus 6 has to be greater than 0. So then we come to, okay, greater than or equal to. Can this number be 0? Can you take the square root of 0? Yeah, square root of 0 is 0. So that is okay. So 3x plus 6 can be greater than or equal to 0. So anything that satisfies this condition will be the domain. So 3x would have to be greater than or equal to negative 6. So x would have to be greater than or equal to negative 2. So again, that interval notation, here's negative 2. We want numbers bigger, and then we would include the -2, because again, it's okay if this expression equals 0. The square root of 0 is 0. So my interval notation is -2 to infinity. So now you had mentioned in your email that you're confused a little bit with the between the greater than or equal to or strictly greater than. So if, let's say the function that you came up with was something like, let's say 2x plus 1 over, let's take the same square root, the square root of 3x plus 6. Now I have a fraction. So that means I have two different things going on here. For one, I can't take the square root of a negative number. So 3x plus 6 has to be greater than 0, right? It has to be positive. But now when I think about it, it can't be 0 because it's in a denominator. So because the square root is in a denominator, I cannot include 0. 3x plus 6 has to be strictly greater than 0. So 3x has to be greater than 6, -6, excuse me, and x greater than -2. So in this situation, it would be from 2 to infinity, not including 2, because, or excuse me, that should be a -2, not including -2 because 3 times -2 is -6, plus 6 is 0, square root of 0 is 0, 0 cannot be in the denominator. So that's the difference between these two. In this one, it's not a denominator, so 0 is okay. In this one, it is. So now the situations where you might get all real numbers. So occasionally, you'll get a rational function where the denominator will never be 0. So like, for example, again, when I look at this, I just think, okay, it's a fraction, so the denominator can't be 0. So x squared plus 1 can't be 0. So again, x squared can't be -1. X squared is never -1. Because the x is being squared, regardless of what you sub in to it, you're going to get a positive number, and you're going to add 1. This denominator will never be 0. So there's nothing to exclude from the domain. So the domain in that case would be all real numbers. So kind of like I said, you really have to consider the unique situation that you're in. These are the most common that you'll see throughout the problems that we've been looking at. Again, just a regular old fraction where the denominator can't be 0, a square root where what's underneath has to be greater than or equal to 0, or that case when the square root is in the bottom and it just has to be strictly greater than 0. So let me know if you have any other questions. Happy to help.